Hello. Good afternoon, ladies and gentlemen. It's a delight to see so many of you here and joining us today for this webinar this afternoon. This is on the Intelligent Dam Monitoring System, or iDMS as we call it. My name's Matthew Coombs. I'm from Binnies, and I'll give you a bit of an agenda, a bit of a rundown of what we're going to do and the timings within that. Then we'll come on to a bit of housekeeping generally, and then we'll play a short video, and then we'll come on to presentations by the other two people that you can see hopefully in front of you here, which is Tim Vallings and Rachel Pether, who will be giving the actual presentations. So just in terms of a bit of an agenda, there will be a short video coming up. That will be followed by about 20-30 minute presentation by Tim and by Rachel. Then we'll have a 10 to 15 minute Q&A session. And please, therefore, if you've got any particular questions, if you could just put them in the chat box, they'll come through to me and I'll make sure all the questions are asked at the end. Should we have more questions than we have time to answer, we'll record the questions and we'll come back to you individually with responses to those questions as they're asked. So if we move on to some housekeeping now. If you could move the slide on, please. Yes, thank you. So your microphones will be muted for the period of the presentation. As I say, if you've got any questions, just put them in the chat box. And once we've completed the questions and answer session as well, we'll have, there will be a survey that will come out to you, but that will come out via email about an hour after the presentation's completed. Be most grateful if you could complete that survey online, please. That would be very helpful to us. So now we'll play, our videos will go off, so the three presenters will disappear. We'll play a short video and then the presentations will be undertaken by Tim and Rachel before we get to the Q&A session, when our videos will come back on and we'll answer your questions. So if we could now play the video and just bear with us for a couple of seconds, because it will take a couple of seconds for the video to load up. Thank you very much.
Imagine if you could access the latest satellite technology to gain unique insights. Insights that support risk management, investment planning, operational activities, and improved reservoir safety. We are fusing traditional engineering and operational practices with big data. Advanced data analytics and machine learning algorithms take thousands of data points measuring movement, vegetation vigor, and moisture over many years to provide a continuous remote monitoring data stream. Dam engineering experts review and interpret data to determine unique basal rhythms for each asset. Each hexagon can be individually interrogated with millimeter accuracy to reveal trends and expose failure indicators. iDMS is a game-changing service built on over 100 years of Binnies reservoir expertise, Binnies digital ecosystem services, and Rezatec's leading geospatial artificial intelligence techniques. It has the power to significantly and positively disrupt the utility sector, future-proofing your dams by harnessing the power of data.
Hello, my name's Rachel Pether and I'm an reservoirs panel engineer from Binnies. And before I start to talk to you about the iDMS product, I thought I would just start by focusing in on why this product is important. Reservoir safety is an area that all reservoir owners are concerned with. The picture that you can see on the screen at the moment is a reservoir in the UK called Tobruk Reservoir. And the spillway at that reservoir failed in August 2019, leading to the evacuation of about 3,000 people who lived downstream. Fortunately, a failure of the entire dam was narrowly avoided. The iDMS tool is designed to avoid circumstances like this, giving owners of reservoirs an understanding of their dams far long before they get to the point of having the kind of catastrophic failure that you can see in the photo here. Next slide, please. So how did the iDMS product come about? Well, at Binnies, we have what we call our Imagineering Hub. It's a part of our innovation strategy. And what we basically do is we look for small SMEs that have work in niche areas, particularly technologies that we can we feel that there's an alignment with the business in Binnies, which is water and the environment. Rezatec is one of these companies. We're working across our business in various areas with Rezatec, and have been doing for a couple of years. I'm now going to hand over to Tim Vallings, and he's going to tell you a little bit more about satellite technology and how this can be used for satellite monitoring.
Thank you, Rachel, and good afternoon, everybody. I appreciate that there will be many on the call today who have never heard of us. And so in summary, Rezatec is an award-winning geospatial artificial intelligence leader, AI leader, and we have a fairly clear vision, which is that the current approach to the monitoring and the management of ground-based assets is always something that we would be wanting to look to improve upon. And in our case, by combining advanced artificial intelligence with leading satellite imagery, what we then are able to do is deliver business information, business insights in a dynamic way, in a dynamic environment, which then allow our clients to optimize resources, increase productivity, make better informed decisions. And these are based both on a retrospective ability to look back, and that's one of the key elements of what we do, because satellites have been capturing data or capturing imagery for a large number of years. And I'll come on to the detail as to the timeframes that are most relevant in this instance in a moment. And so we can look back in time, see what has occurred in the past, and then remain current and up to date with occurrences as things then move forwards. So we were founded in 2012, and the team has grown to over 50 individuals now, largely made up of PhD data scientists and Earth observation experts. So most of that 50 to 60 people is around the delivery and the development of product using world-leading specialists in their particular fields. And we deliver those geospatial analytics as a service to then 4 key verticals, which you can see on the screen now. But to be clear, we are not, for example, dam monitoring experts. You are the experts, Binnies are the experts, and the panel engineers and so on, and all of that expertise that you as individuals have and that Rachel and her colleagues also have. What Rezatec is a software expertise enterprise, and we support the work of Binnies and our clients with product, with layers of data. And we've spent time over the last 9 or 10 years or so making sure that that data we provide is in relation to the needs of the end users, with which they are then able to make more efficient, cost-effective decisions, as I've mentioned already, or indeed safety-based decisions, profitable-based decisions. And it enables us always to understand the client markets, focus that development and delivery on the areas that matter to clients as a whole. So as we move on to the next slide, this is all about how do we do what we do. So I've told you a little bit about Rezatec, the company, and now what I want to do is spend just a little bit of time running through methodology in relation to the dams vertical, the dam sector. And what we use primarily are a couple of synthetic aperture radars, or SAR. We use C-band synthetic aperture radar from satellites. And we also use what's known as X-band data. And they come from an increasing number of commercial satellite operators. Now, on the very left-hand side of the screen, you'll see that historically, the European Space Agency's ERS 1 and 2 constellations and their ENVISAT mission. So these are all different types of missions, of satellites, of constellations of satellites that have gone up over the years, going all the way back to 1991. And they were providing resolution of about 30 meters. It was essentially C-band SAR data, and it had revisit cycles of about 35 days, so just over a month for every time there was a new image that could be captured. And then more recently, which is what's been much more game-changing up since about 2015, the European Space Agency sent up what we would refer to as being the Copernicus suite. And they are a series of Sentinel satellites, and you'll see images of both of those satellites towards the center of your screen at the moment, one referencing SAR and the other referencing multispectral. And these have been in commission since about 2016. So they went up in about 2015, and since 2016, we've been able to use these satellites in our work with dam operators. And that is why it has been an evolution in the capabilities born out of this source material, because these satellites come with resolutions down to about 15 meters for C-band and about 10 meters for optical. Not only that, they have a revisit cycle of about 6 days. And what this means is that we can refresh your assets every 6 days in our systems and be looking for multiple imagery passovers with which we can then do our analysis. So really, that Sentinel commissioning is when there has resulted in a genuine evolution in those capabilities from satellite technology. And that is now benefiting those in the dam monitoring sector, because Rezatec becomes then responsible for turning the various source materials into detailed and highly accurate views across entire asset bases. Now, there is no limit to the scale of that coverage, meaning that you could look at one dam or you could look at a series of dams spread across an entire nation. And it has been created as a platform to be wholly agnostic regarding the sources that are inputted. And what I mean by that is that we will always look to acquire the most appropriate data, whether that be from multispectral optical indices or from radar. And those are the ones, as I say, that are captured on the screen at the moment. But we can also capture Earth observation data sets such as aerial imagery, environmental data, weather data, LiDAR, which tends to be flown on drones or helicopters, client captured, existing and indeed historic information, all of the information that could be considered relevant for an analysis can be incorporated and included in the analysis and then correlated with the satellites. And this is important because satellites operate in very different conditions and they do different things. So radar is always looking for surface structure. So that's used when we're looking at the dams themselves. And that's important when you're considering the movement of dams and indeed the ground around those dams. Multispectral indices are what can be broken down into indices such as infrared and your standard RGBs, so your reds, greens and blues and so on. And we use those once they've been broken down to then analyze and build up product around the look-sees for things like vegetation color, chemical composition, cell structure and moisture. And this is useful when you're looking at trying to distinguish between various vegetation conditions. And of course, both of these things, both structure and vegetation condition, can then be monitored over time for change. And our data science teams apply these algorithms, so they are our algorithms that we have built ourselves, and using machine learning techniques, including elements of statistical analysis to be able to provide results around accuracy back to the clients, in order to interpret the source material into these meaningful outputs. So this is not about providing imagery, it's about providing product that speak directly to the needs of the client. And you'll see this in a moment when Rachel takes you through some of the platform. And it can then be updated as required, as needed, over, as I say, an area of interest that allows for a comprehensive view of a particular land base. So it can be, as I said earlier, one dam that you might be looking at, 2 dams, 3 dams, or a whole series of dams over a very widely dispersed area, perhaps even at the nation state level, rather than having to always focus on a single entity. And all of these can then be captured and presented to the client through the iDMS platform. So just finally, you'll see on the screen now some bullet points to the right-hand side, and these include, when you're applying them specifically to dams, things like the routine monitoring of gradual change and the identification of symptoms of change. And it mentions there also things like catastrophic change on the slide. This solution is really designed to give you an ability to look retrospectively, as I've mentioned, for years. And we usually start at a sort of 3-year standard retrospective for you, as well as currently, in order to build up a pattern of behavior and therefore then ultimately to avoid events that might or could be considered catastrophic. And these outputs are using indicators like the ground motion, soil moisture, vegetation, slope, and so on. So that gives you a little summary of how we do what we do, and indeed what are the outputs around vegetation condition and structural movement of dams and the land around it. So at this point, I think in order to make this a bit more visual for you, I'm now handing back to Rachel, who can conclude the presentation for you with a presentation of the platform itself.
Thanks, Tim. So yeah, I'm going to take it back to maybe something slightly less high tech, and show you what this actually means for you as a client. So the view that you can see on the screen at the moment is a cut from the iDMS portal. So the portal is accessed by the website. So all we do is send you a link, and then you will have login details. So within your organization, you can have as many people with login details as you would like, and they will all be able to come in here separately and see the data. So you can see on there that there's a couple of locations highlighted on the map of the UK. So essentially what you would get for your assets is a similar map of your region with whichever dams you were monitoring highlighted. And in order to decide which dams you are going to monitor, all you need to do is tell us which ones you're interested in, and we can take a look at them, do an initial assessment to make sure that we can get good readings from that dam. There's no need, we don't visit the site, there's nothing that we need to install at the site, it's all entirely remote, so there's no site visits involved at all. It's all done entirely remotely using the satellite data. So if we go on to the next screen, this shows what you'll see if you zoom in. So you can zoom in on the menu on the left just by clicking on the name of your reservoir, or you can also zoom in and out with your mouse in the usual way that you would on your computer. You can also view it on, as well as on a computer, you can view it on any, so you can, if you wanted to, you can view it on an iPad, or if you want to look at it on your smartphone, you could, although obviously the screen's going to be very small to see any detail. So you can see on this particular reservoir, the dam is on the right-hand side, and each of the hexagons represents an area of about, the length of each side of the hexagon is about 9 meters long, and each of those areas has 3 data sets behind it. And the data sets that we provide are movement, so settlement, vegetation moisture, and vegetation vigor. And you'll also see on the left-hand side, in the bottom left-hand corner, you can see the amber and the red. There's nothing highlighted on these dams at the moment, but part of the service that we provide is we analyse the data for you. So our reservoir experts analyse the data for you, and we set trends so that you can understand whether the movement of your dams is what we would term as normal movement, or whether it's starting to move outside of those constraints. So an amber would be a dam that's moving a little bit outside of what we would expect, and a red is where we think there's some significant movement. So how do we provide the ambers and the reds for you from day one of your monitoring? Well, the service that we provide, as Tim has mentioned, the satellites can collect data retrospectively. So what we do is we collect the previous 3 years worth of data for your dam on all of these data points, and we use that to set those initial limits. So that basically from day one of us monitoring the dam, we've already got 3 years of data on your dam, so that we can immediately start to understand what is and isn't normal, and when those amber and those red alerts come up. And from looking at that data, which is weekly, so we've got weekly data on each of those points, we can really start to understand what's normal movement for the dam and what is something that we think would be of concern. So if we go on to the next screen. So the next screen just shows one of the movement points. So as you can see, that's one of the, if you click on any of the hexagons, then it will immediately come up and show you the movement for that graph. You can see the time slider at the bottom, so you can choose to have show all of the data if you want to, or you can focus in on a particular area. So as you can imagine, if you've been monitoring the dam for say 10 years, then you may well want to just look at the last few years. As well as that movement data that we have there, we also have the opportunity to add in any other information that you may hold. So we can add in things like if you have telemetry giving you reservoir levels, we can add that in. If you've got piezometers on the dam, then we can add that information in as well. So anything, basically any other data sets that you want included, then we can include those as well. So if we go on to the next slide, please. So the next slide is similar, but that's for vegetation moisture. So vegetation moisture and also vegetation vigor, what we're looking for there is indications of seepage, so water moving through the dam. So although the satellites, you know, they don't have sort of X-ray vision into the dam, so they can't see water moving at depth within the dam. Wherever that water surfaces out of the dam, so on the downstream face, then you would tend to get an increase in the vegetation moisture and vigor in that area. And by monitoring it weekly and having that information over a long period of time, including that retrospective analysis, it gives you the opportunity to really understand what is normal annual changes in those variables between, say, summer, spring, winter, and what is something that's, you know, a trend towards becoming more moist or having vegetation that's growing more vigorously. So the final slide is exactly the same, but for the vegetation vigor. So again, you can see the changes. So as you can see, there's an awful lot of data there: movement, vegetation, moisture, and vigor, and it's really through the red amber system that we're applying our engineering reservoir expertise to give you something that, as a client, you have that information. So you'll be able to go into the portal and see immediately for your dam, yes, everything's fine, or oh, there's something that's a little bit different. And what you'll also get is you'll get information from our reservoir engineers coordinating with that, those any ambers and reds, to give you an indication of what we think the issue is and what we think you should do. So for example, if you've got one isolated amber, then it may well be that we would say, okay, well, it looks like this area is beginning to move in a way that's unusual. We think when you go out and do your regular site visit, this is an area that you would want to have a look at and you know, start to have a think about what might be happening there. Obviously, if we had a large cluster of red hexagons, then that would be far more significant, and we would be flagging that up as, okay, well, something is in this area is definitely happening that we should be paying attention for and looking at in a bit more detail. So in that way, it's a really good tool to get a very early indication of movement and also indications of seepage long before they would be visible to the human eye just by walking along the dam, and also at a much greater coverage than you would normally be getting if you're doing a survey of the crest of the dam, say, once a year and only at 20-meter centres. So you're really starting to build up an understanding of the whole of the dam and also how it changes throughout the whole of the year. So that was all that I was going to show you on the portal. So I think I'm handing back now to Matt for questions.
Yes, thank you, Rachel, and thank you very much to Tim and Rachel for the presentations. Pretty enlightening, really, and it's good to see the way technology's developed and what is available now, and how things like this can be used to complement all the other systems that we generally have on dams, such as our piezometers, hopefully CCTV, drone surveys, those kind of things as well. So it's another element to all of those different monitoring systems to hopefully help protect our dams. So thank you to everybody online as well for bringing in a number of questions. I'll try and group these questions as best I can for both Rachel and Tim, so hopefully they follow through in some sort of logical order. So Tim, with regard to the satellites, there's a question about reliability. So the question was really, do you get any reliability issues with the satellites themselves?
Okay, so that's a good question. So I'll answer that in just two quick ways. Firstly, the platform, as I say, is designed to be agnostic, and therefore what we're always able to do is look for any available data that might exist. And sometimes you are right that the various orbits or the projections of a particular satellite doesn't give as good as a response as others might. So we have that ability to be looking around. Radar is obviously not doesn't have any problem with seeing through cloud or through or can be used at night, for example, because it's looking for solid structures and it's projecting back an image on that sort of a basis. Of course, optical satellites, they are obfuscated by things like cloud, and they don't operate at night. But because of the Sentinels having gone up in about 2015, as I mentioned, one of the key advantages of those constellations was the frequency with which imagery can be captured. So it's capturing more or less the whole world every 6 days. And what we're looking to do is to update the system on a, if you like, on a sort of monthly basis. And it allows us then to draw on multiple passovers during the course of a month in order to gather information. So if it is cloudy for 30 straight days, then there will be reliability issues associated to the optical data sets. There won't be those same issues with radar because that's not an issue for it. But it's usually quite rare for that to occur over an extended period of time. The second one, the sort of second point that I would make on that is that because we've been doing this for quite a long time, we've been able to establish relationships with different satellite operators, different satellites that are up there. And that will always then give us an opportunity to look for alternatives if there are issues with particular satellites that we may be aiming to use. Now, the final point is just on the signatures that then come back from a particular point on the ground. And what we always ask is clients, if they could give us or make us give us the list, if you like, of the positions of all of their satellites, then what we can do before they're committed is carry out a feasibility on each of those satellites to see how much of a signature is being presented back to, in particular, to the radar, the synthetic aperture radar satellites, in order to make a decent assessment on a case-by-case basis as to which ones would be able to be assessed. But under normal circumstances, when you can see this, when you can see the dam, regardless of where it may be, and you've got a window within the course of a month of cloud-free imagery for the optical, then you should be fine when it comes to reliability.
I think you've probably actually answered one of the other questions that came through as well, which was what is the coverage, i.e. is most of Europe covered? But from what you said just then, it sounds like the whole of Europe should be covered.
Most of the world, in fact, is covered. So one of the benefits of the European constellations is that they aren't limited to Europe. They are focused around a global coverage. So they, I mean, for what it's worth, they're also imaging the oceans as well, depending on which Sentinel that you're looking at. But in this instance, we're much more interested, obviously, in the land-based coverage. So we focus our attention on Sentinels 1 and 2. And apart from the sort of North Pole and the South Pole, and maybe a few degrees either side of that, largely the rest of the world is captured. And it's not, as I say, exclusive to Europe. And although the European Space Agency sounds like it might be, no, they're capturing. And in fact, you don't even have to be in Europe to be a member of the European Space Agency. So Canada is a contributing member of the European Space Agency and is part of the work done. So anywhere in Europe, you would be able to get imagery both from a synthetic aperture radar perspective and from an optical perspective, and that would be sending back signatures every six to 7 days, which we would then collate, analyze, and present as product back to Binnies for further analysis and sharing with the client.
Thank you, Tim. That's very comprehensive answer. Some ones which follow on from that, really, probably for Rachel, I would guess. So there's a question about where the system is currently being used, Rachel.
Yep, sure. So Rezatec has started monitoring dams. They've been doing it for a few years now. So in terms of just the plain monitoring of the dams before aside from iDMS, they're doing that for clients in Australia and also in America. In terms of the iDMS tool, which is the partnership, where we're bringing the Rezatec sort of specialist satellite knowledge and also layering that with the reservoir expertise. We launched that earlier this year and started our first pilot study, which is with the Canal and River Trust in the UK. So the Canal and River Trust is actually the owner of Toddbrook Reservoir, which is the photo that I showed earlier, and they had a significant dam failure back in August 2009, which very much focused their minds on reservoir safety and improving their systems, and they really see the iDMS system as a way of doing that. So that's our first trial that we have, pilot that we have underway. We're also talking to other clients in the UK and Europe and also in Asia. And I'm sure we will have others following soon in the Canal River Trust's footpaths.
Okay, thank you. And there's two slightly more technical questions perhaps, and probably one to Rachel and one to Tim. One is about what is the frequency that the information is provided to the client. I think Tim outlined very clearly how frequently the satellites go over and the data is available, if you like. But the specific question is along the lines of the client availability to the client.
Yeah, so what we do is we don't release the data on a weekly basis, because that would be quite difficult for the client to have to keep updating it on a weekly data basis. So what we do is we bunch the data together in monthly, and then the client will get a monthly update to the portal. So as part of that, they're getting the new data for that month, and they're also getting the analysis in terms of the red and the amber, so they can go on each month and have a look what's happened, what's happened where they were. Maybe if there was an amber last month, is it still amber or has it cleared? And is there anything new that's developed on that dam? So they can see that on a monthly basis, which is a reasonable frequency for them to have sort of good understanding of the dam without it becoming an overwhelming obligation and something that's sort of very time consuming in what we know as people's already very busy schedules.
Okay, this one I think is probably more for Tim, but it might be yourself as well, Rachel, which was around what is the accuracy of the system?
So continuous coverage and developments in SAR phase data analytics as a result of the constellation from the European Space Agency going up in 2015 has enabled what we would refer to as precise orbit determination. And in sort of layman's terms, what I mean by that is that whenever the satellites, especially from a radar perspective, are orbiting the Earth and they're taking their images, when they repeat that, so they've gone full circle and they come back to take a photo of the same site, what we are able to do is establish that precise orbit determination, that location. And we can do that down to 2 to 3 millimeters of precision. And that comparison, once we understand that from a satellite's positioning perspective, enables us to understand what kind of movement down to that similar level of precision, that's sort of 2 millimeters or so, is occurring on the ground. So movement readings, which are sensitive to that sort of 2 to 3 millimeter of movement between each observation, allows over time, when you're doing, if you like, post-processing, and this is one of the key reasons why you would want to take a longer term view, is that you can get to a very high degree of precision in terms of location measurements, let's say over the course of a year, whereby if there is movement of 2 or 3 millimeters or more, that can be picked up, identified, and you have a high degree of precision associated with knowing that is the case. And as I say, the reason we've been able to do that is because of that precise orbit determination. And really, I'm not kidding. It's down to that sort of 2 millimeters of precision. And because we know that with the satellites, so we can then apply it to movement that then occurs on the ground and calculate the various measurements associated to that.
Okay, thanks, Tim. There's another question that's just come in, which is related therefore in terms of what, well, there's sort of two parts. What surfaces provide the best readings? And it says, water was mentioned, water, paving, vegetation, and or affects the accuracy. So in relation to that 2 or 3 millimeters, is there a particular surface?
So again, good question. I've touched upon this already. The radar is looking for surface structure. So that doesn't get in the way, you know, canopy cover won't get in the way of that. The clouds won't get in the way of that. And so it's looking for solid structures. So iteratively then, the more solid that is, the better the radar likes it. So when we're looking at a dam, we're looking at the structure of the dam itself and the associated embankment side bits and so on, not so much the water contained within the dam. So we're looking at the structure of it, and the radar likes the solid structure that dam has been made out of. When we're looking at indications that might be taking you down the route of seepage and so on, that's where we're more interested in using the optical data satellites, and we're looking at vegetation. So the radar won't really help us with seepage, and that's why as a company we have to combine the two in order to be able to give a more holistic response back to the client. And cell content, moisture, and so on is all picked up once you break down the optical data into its various multispectral indices. So what that's looking for is changes in cell content, cell moisture, canopy cover, vegetation. So what that's interested in is trees, foliage, and grassland, and so on. And when that changes, and obviously in collaboration with a client, if there's an embankment which is being, for example, mown, that will show as a change in an optical assessment. But obviously if we know that's happening and the client knows that's happening, then it need not be an alert, it just need be something that everyone is aware of. So that on an optical side, they prefer the vegetation and the radar prefers solid structure.
Excellent, thank you for that comprehensive answer. Can I just, we've come to the end of the questions, and it was only supposed to be a 10 or 15 minute slot for the questions anyway, so we haven't really got time for too many more. Just one question can I ask myself, actually, just as we're running through, is the following on from the optimal information that you were talking about. Obviously this presentation is just with regard to dams and monitoring of dam structures, but embankments, there's obviously large embankments linked with flood storage schemes and all matter of other things as well. So this system is applicable to those as well.
Yes, absolutely, and we're very happy to talk to clients who may have sort of other structures that they think might also benefit from this type of monitoring.
Okay, thanks very much. Thanks, Tim and Rachel. Right, I think that draws the questions to a close. So we'll bring the meeting to a close now. Just one final thing for those online, just to say, or to repeat what I said earlier, there will be a questionnaire coming out to you via email, probably in about half an hour after the presentation's concluded. We'd be most grateful if you could complete that online questionnaire. That would be great if you could. So otherwise, once again, thank you to the presenters, and thank you to all those that have joined, and we look forward to discussing matters with you in due course. If anybody wants any more information, just contact any one of us, and we'll come back to you with more details. Okay, so thank you very much to everybody.
Thank you.